Hey everyone! Now recently, me and my friend Caden just took the Algebra 2 EOC final, and let me tell you, it was not pretty. Imagine Session 1 being like getting run over by a Soviet tank. Imagine Session 2 being like getting run over by the same Soviet tank while still injured. Alright, I'm just exaggerating, but let me tell you, I still hope there's a curve on it. Alright, I remember this one question that made me think, wow, I needed to refresh on this topic. I should have done it before I took the test. It involves solving rational-like equations with an I in the denominator. Now, before we tackle this problem, we gotta ask ourselves, what is the I in the denominator? Now, that I is something known as an imaginary number. Imaginary numbers are a way to describe radicals with a negative number in them. The letter I is equal to radical negative 1. Radical negative 1 cannot be reasonably calculated, hence why I is imaginary. Imaginary numbers are part of a binomial expression called complex numbers. Complex numbers include two terms, one being a real number, which includes all rational and irrational numbers, and an imaginary number, which includes all those numbers with the I in them. Now, an example of an imaginary number is 3i. If you condense 3i further, it equals radical negative 9. How would those two relate? Now, radical negative 9 is the same thing as radical 9 times radical negative 1. If you square root 9, it'll equal 3. Radical negative 1 is left, which is the same thing as I. Combine the two, 3i. Now, also another thing to keep in mind is that I squared equals negative 1. Why? Well, if you multiply two of the same radical, then you'll have the same number inside the radical. Radical negative 1 times radical negative 1 is 1. Now we'll start by solving this first equation, 3 over 2i. Well, Houston, we have a problem. You cannot have an imaginary number in the denominator. It's the same reason why there cannot be any radical in the denominator. Think about it this way. Can you divide 7 by 0? No. A number cannot be divided by something that does not exist, like that girlfriend you claim to have. Just kidding. But this means you must solve this equation by multiplying the numerator and the denominator with a copy of the denominator. What did that even mean? Alright, I'll show you here. 3 over 2i. You must multiply each side by the 2i. This will equal 6i over 4i squared. Now remember, I squared is equal to negative 1, so you should substitute it with negative 1. This will end up giving you 6i over negative 4. Simplify that and you'll end up having negative 3i over 2. The point of this is to end up trying to getting rid of the I in the the denominator. The I is the same thing as having a radical in the denominator, which you cannot have. Now we're not done yet. You must separate the I from the fraction in order to have a complete complex number. I'll talk about this later on. But what if you have a nasty looking complex number in the denominator? Example being 3 over 2i, 2 plus i. Well, instead of multiplying the numerator and denominator with the imaginary number in the denominator, you must multiply with the conjugate of the denominator on each side. This will end up rationalizing the denominator, so you may have a complete complex number. You start off by multiplying each side by a 2 minus I. This will end up giving you 6 minus 3i over 4 minus I squared. 6 minus 3i over 4 minus negative 1. Remember to always substitute the I squared with negative 1. This will end up giving you 6 minus 3i over 5. Now, this is not the complete answer. You must simplify it so you end up having two terms, the 6 over 5, which is the real number, and then 3 over 5 I, which is the imaginary number. The final answer should be in the form of a complex number, which includes both the real number and the imaginary number. That concludes all today, folks. Thank you for watching.